So this is question 1. We've got a sector of a circle. The angle we don't know, but we know the radius is 5 and the arc length over there is 4. Okay. Find the value of theta. There's 2 equations that I can use for these things, aren't they? There's the equation for the arc length. That's that bit there, a bit around the outside. What's the equation for the arc length? Anybody? R theta, yeah. And what's the equation for the area of the sector? Half r squared theta, Bill. So those are the 2 things that I really need to know for this. So if I want to know what theta is, okay, I've got r and I've got L. So theta, from this first one here, theta should be L divided by r, and the length is 4. Is it? Yeah. And the r is 5. So theta should be 4 divided by 5, which is 0.8, isn't it? Do you agree with that? Is that right?
Yeah.
Yeah, cool. And then it says find the area. Well, the area is just 1/2 r squared. Well, that's 5 squared, that's 25, times 0.8, which is 1/2 is 0.4 times 25, right? 0.4 times 25. 0.5. Is that 10? Is that 10? Yeah. Cool. 10 centimetres squared, right? Okay, who managed to do that? Easy question, right? Sorry. Question 2 is just an index question where it's asking you to tell me what the values of P, Q and R are. Okay, so this is just testing whether you can do indices or not. So the first one, 8 equals 2 to the power of something. 2 to the power of what equals 8?
3.
3, so P is 3. Okay, simple as that. Now, the next one is 1 over 8 equals 2 to the power of something. Now if it's 1 over, what does that mean the power is? It's negative. So what's Q then? Minus 3. Okay, the minus makes it the reciprocal, so the minus makes it 1 over, and it's still to the power of 3. Okay, so the power is 3 and the minus makes it 1 over. And then the final one, we've got the square root of 2, so what's R? A half. Okay, so when you've got a fractional power like that, the number on the bottom of the fraction, the denominator is the root, and the number on the top is the power. Okay, do you all remember that? Everyone got those? That's 3 marks if you got those. Okay, so the next part then says, now you've done that, can you find the value of root 2 multiplied by 2 to the power of x, find the value of x when that equals an 8th. Right, can someone talk me through how to do that then, please? Say again, sorry. So Shannon's saying this. We've already know that 1 over 8 can be written in terms of 2. So it's actually 2 to the power of, what did we say it was? Minus 3. Is that what you're saying, Shannon? Yeah, okay. Okay, anything else?
Root 2.
Yeah, the root 2 we can write as 2 to the power of a half. So it's 2 to the power of a half times 2 to the power of x is equal to 2 to the minus 3. Now what's the rules when we multiply these 2's together? What happens to the powers? What happens to the powers when we multiply those 2's when they've got the same base? So again, add. Yeah. So this means that 2 to the power of 1/2 add x is equal to 2 to the power of minus 3. We don't actually need the 2's anymore. We can just say that x plus 1/2 is equal to minus 3. So x is equal to minus 3.5. Is that right? Do you agree with that? Or 7 over 2. Negative 7 over 2. what have we got to do on this one? Show that the angle is 97.9. How do I do that? What am I doing here? Cosine rule, right? Is it? What's up with you all? What's the cosine rule? A squared equals b squared plus c squared. So if you can't remember it, it's like Pythagoras. And then you take away 2bc cos A, yeah? Now we're trying to find the angle, right? So we've got to rearrange this. So do it one step at a time. Bring the b squared and the c squared over. So a squared minus b squared minus c squared equals negative 2bc cos A. Then what I'll do is times this by minus 1. Okay, so it's going to get me b squared plus c squared, take a squared, is equal to 2bc cos A. Then I'm going to divide by 2bc. So I get cos A is equal to b squared plus c squared, take a squared, divided by 2bc. Okay, is everyone happy with that? And if I want a on its own, then what I do is I just do the inverse cos function. Stick that there. Inverse cos of all of that. Just put a little bracket around it. Inverse cos of all of that. Okay, will give me the angle. So let's just bungle all that stuff in, yeah. Okay, so theta should be cos to the minus 1. Right, now, first of all, I better label it up, hadn't I? That's A, so this is going to be A over here. Does it matter what B and C are? Doesn't really, does it? Should we do it like, oh, I'll tell you what, we'll label it how they've done it on there, shall we? So should we call that one B? And that one C? Okay, so B squared, that's 8 squared, plus C squared, that's 5 squared, take away 10 squared, all divided by 2bc, so that's 5 times 8, that's, what's 5 times 8? 40, right? Is this 80 underneath? Am I talking sense, is that right? Okay, cool. Getting better at maths. Okay, so this is 64 plus 25 minus 100 all over 80. Well, I've got to do the inverse cosine of that. Okay, so let's just whack this in the calculator, shall we? What was it? 64 plus 25, take away 100, divided by 80. Wicked. You've got to make sure this is in degrees, right? Yeah. Okay, so inverse cos of the answer. Did you get that? 97.9. That's what you're trying to show, isn't it? That's good. Theta equals 97.9. Everyone managed to do that? Okay, next part. BI. It's asking you to find the area of the triangle. What's the formula for the area of triangle? Half AB sine C. Okay. Now that's how you write down the formula, but the sine, it's going to be sine of the angle, so it's going to be sine of that angle there, and then the A and B are going to be the other side. So the area of this triangle is 1/2, and what was it? It's going to be 5 times 8. 5 times 8 sine 97.9. Do you agree with that? Okay, so whack that all in the calculator. That's not the calculator. What's the calculator? That one. So that's 4 times 5 plus 20, and then I'm going to times it by sine 97.9. 19.8. Right? 19.8. Who got that? Is that right? Have I done it right? Anybody? Is that right? Yeah. Okay. Okay, finally, the last bit of this question. Some people are asking about this, so let's just have a quick look at this for the last bit. It then says, let's draw a line perpendicular from A to BC. So that's saying, let's put a line in here, like that. That's going to be the height of the triangle. Would you agree with that? Okay. It's asking you to find the length of that line. I'm going to call it the height of the triangle. Okay. Height. Okay. So when you're doing your GCSEs, the height of the area of a triangle is half the base times the height. Okay. So half the base is 5. So what we should be saying is this: 5 times h, 5 times the height, should be equal to 19.8. Is that true? So the height is 19.8 divided by 5. .96. Is that to 3 significant figures as well? 3.96 centimetres. Okay, and that's the height of that perpendicular. Everyone agree with that? Okay, so this is question 4, and it's a trapezium rule question. Now some of you were asking about the trapezium rule the other day. The trapezium rule is in your formula book. Can someone tell me how it's written down in the formula book? If I just write down the trapezium rule here. What is the trapezium rule for, first of all? What do we use the trapezium rule for? Yeah, well, I've got a graph here, yeah. What is it? What does your trapezium rule tell you? Yeah, it tells you the area under this curve here. Okay, so there's another way we can find the area under a curve, and that's to integrate. So what the trapezium rule is saying is, if I integrate this curve between B and A, so between some point B and A, and I integrate that, the trapezium rule will tell me what it's approximately equal to. Why would you use the trapezium rule rather than integrate something? Because the integration will give you the same answer. Well, the integration will give you an exact answer. This one's just an approximation. That's why we've done this squiggly equals. Why would I use the trapezium rule rather than just integrate? Say again? Anybody? Yeah, it's, for example, this curve here, you can't integrate that one. You guys don't know how to integrate something like that. Okay. Now, if it was a curve like x cubed plus 4, if it was just the thing underneath, you could integrate that and you'd get the answer. That thing with the square root over it is very difficult to integrate. Okay. So we can't integrate it and just get an answer. What we're going to do is a trapezium rule, and the trapezium rule basically says split it up into lots of trapeziums and find the area of each trapezium like that. And just add up the areas. So rather than integrate, we're going to add up the areas of those trapeziums. Okay, does that make sense? So what's the equation then? Can someone tell me the equation? It's in the formula book. Can someone just, it's right there. How's it written down in? Just pass it me if you want. Let me write it down how it appears, right? Okay, so it says half of h, so h over 2, and then you multiply y0 plus yn, and then it's plus 2 lots of everything else, isn't it? How's that? Okay, so that's the trapezium rule right there. Okay, so let's have a look at how you do it. Once you know the trapezium rule, all you have to do is sub into it. Okay, so this question says, can we find out the area under this curve between 0 and 1.5? Okay, so the x values I'm looking at are from 0 to 1.5. So I'll put those in. We're going from 0 to 1.5. And it has asked us to use 3 strips. So there's my 3 strips. So what are the other x values here? What's the x value for this point here? Yeah. Yeah, and that's 1. Does everyone agree with that? Okay, is everyone happy? Now I'm just going to label this up so we can plug it into the formula. This first value here, this is x0. This is x1. This is x2. And this is going to be x3. Okay? And what I would do now is this is how it appears on the mark scheme. I would write these down in columns. Okay? So for every x value, x0, x1, x2, x3, there's going to be a y value, the height of it. So the x value tells me where it is across, and the y value is how high it is at those points. And that's all I need to find the areas of these trapeziums. How do I find the y value at each point? I just put the x value into that there, and it will tell me what the y value is. Okay, so let's just do that. So I'll come down here, and I'm going to write down x0, x1, x2, and x3. And x0 was 0, x1 was 0.5, x2 was 1, and x3 was 1.5. Okay, everyone happy with that? So over here, I've got a y0, a y1, a y2, and a y3. y0. So when I put 0 into this equation, when I put 0 in for x, I get 27 times 0 plus 4 and then root it. So what's the answer? 2. Okay? Right. When I put, Charlie, when I put 0.5 into there, let's have a look what we get. We've got a calculator here, so it's going to be 0.5, and then I'm going to cube it. I'm going to times it by 27. I'm going to add 4. And then I'm going to square root my answer, and it gives me, let's write it down like this, 2.715695123. So I'm going to write that down, okay? What did I get there, sorry? 2.715695. Let's just go to there. 2.7. I've forgotten it again. 156. 15695. How's that? Is that good? 95. That'll do. Yeah. Okay. For y2, I just got to put 1 in. So when I put 1 in, I'm going to get 27 plus 4, which is 31. Root 31. So I'll just do root 31 in the calculator. Root 31. Okay, 5.567764. What was it? 5.567764. Charlie, paying attention. And then I'm going to put 1.5 in. So I do 1.5, I cube it, I times it by 27, I add 4, I square root the answer, 9.753205, okay? 9.753205. Yeah, you could just whack it all into a calculator and long go, put it in there. But I do it like this. The reason, it's a good question, Soph, why don't you just whack it all in? You can just put it all in the calculator. If you write it out like that, they do check. On the mark scheme, it will look like that. So if you whacked it in the calculator, you got it wrong, you wouldn't get any marks. Whereas it will check whether you got what you got for y1, y2, y3, like that. Okay. If you get it right, you just get it right. Okay. It's after 3 significant figures, so I'm going to add it all up and then we'll just round the answer. Okay. If I was doing, me personally, there's a few ways you could do this. You can do it like Sophie said, you can just put the values into the formula. You can do it all on your calculator and it will just read them off for you. You can do it like that. I think I've shown you how to do that on one of the videos before. Now the way I would do it is I'd write down the x values, write down the y values like that so that they can mark them, check them got right. And I would actually write down the whole calculator display there. Now, it's hard for me to flip between them, but when you're doing your exam, just write down what's on your calculator. Okay? But we'll put them all in and then we'll round the answer at the end. Okay? So now all I need to do is just say, okay, that area under the curve then is going to be h over 2. Now what's h in this case? H is this distance here, so it's 0.5. So the integration between 1.5 and 0 is approximately equal to h over 2, so 0.5 over 2. And if you look at the equation, it's the first y, y0, plus the last y. If you look at the equation that we wrote down, this is how you remember it. It's the first y plus the last y, and it's 2 lots of everything else. Okay? So it's the first y, the last y, and 2 lots of everything else. So the first y is 2, the last y is 9.753205, and then we add on 2 lots of the others. So 2.715695 plus 5.567764. Okay, and then you just whack all that in your calculator, so let's do that quickly. I'm going to do this bit in the bracket first, so it's 2 plus 9.753 205 plus 2 lots of 2.715695. Have I done that right? Plus 5.567764. Close the brackets. That's everything inside the bracket, and then I'm going to times it all by 0.5 divided by 2. So I'm going to times it by 0.5, and I'm going to divide it by 2, and that should be the answer there. Is that right? Who got that? Yeah? And it says, can you put your answer to 3 significant figures? So what would that be? 3 significant figures there. 7.08. Okay? Now, what was it, 7.08? Brill. Okay, so who managed to get there? Right, it should be a pretty straightforward question, the trapezium rule is. There's a couple of other things I could ask you about it. It takes quite a while, but it's as long as you follow the right instructions, you're all right. How accurate is the answer?
No.
Beth? Say again? It is an estimate. How would I make a better estimate? How could I make a better estimate?
No.
Just increase the number of strips. Okay, it's going to be more accurate if you put more strips in. Okay, that's the first thing. Also, not totally sure by this graph, but I think it's going to be a graph that goes up like this. If you get a picture of the graph, in this one you don't get a picture of it, but let's say you did. I think this graph is probably going up like sort of like that. Okay. Is my estimate going to be an overestimate or an underestimate? Over, yeah, because you can see that the trapeziums are just going to slightly go over every time. If the curve was this way round, and I start doing trapeziums, you can see they're always going to be a little bit under. Okay, so if you get a picture of the graph, and you've done it using trapezium rule, if it's a graph that's shaped like that, like bowl shaped, okay, the trapeziums are going to be over it, and it will be an overestimate slightly. Okay, and if it's the other shape, like a convex shape, then it's going to be under. Now the next question, there's part B for this. It says we start with this curve y equals root of 27 x cubed plus 4, and it says it's stretched parallel to the x-axis, so it's stretched in the x-axis scale factor 3. What's the new equation? Any guesses? Does anybody think they know? Okay, so what we do here is, it's a scale factor of 3 in the x direction. So that means, listen please, because it's important this is, that means that it's the x that changes, and it's changed by the opposite of what you think. So this would be y equals 27, keep that there for the time being, change the x for x over 3, okay? So that's what you got. The x has changed to x over 3, okay? Which means that this whole thing becomes 27 times x cubed over 27 plus 4, which goes to just x cubed plus 4. So this is question 5, which is to do with binomial expansions. You could multiply this out, but it's really testing your whether you can do binomial expansion. You'll have in the formula book a way of doing this expansion here, 1 plus x to the power of n. Okay, that's a general expansion. And what you get is you'll get x to the power of n plus n choose 1 times x to the power of n minus 1 plus n choose 2 times x to the power of n minus 2, and this just keeps going, okay, until you get to n choose n x to the power of n minus n, which is 1, yeah, x to the power of 0 is 1. Okay, so what we're going to do is we're going to do the expansion of 1 plus x to the power of 3, because that's almost the same as the one we want to do, and what we will get is x to the power of 3, and then we're going to get 3 choose 1, which is just 3, x to the power of 2, and then we're going to get 3 choose 2, which is 3 again, and then we're going to get 1 on the end. So that's the expansion of that. Okay, so the expansion of 1 minus x, well, the only difference is that the x is now a minus x. Does that make sense? So I'll go through the expansion I've just done, and I'll change all the x's for minus x's. But that means that I have to cube them and square them, and that's usually where people go wrong with this thing here. So minus x cubed goes back to minus x cubed, and minus x squared makes it plus, and then we've got minus 3x and then plus 1. So that's the expansion there. That's what you should get. Who managed to do that? Everyone happy with that? Okay, cool. So that's part A. For part B, it's asking you to do the expansion of this thing here, and it requires you doing the expansion of 1 plus y to the power of 4. So you should be able to do this one as well. This should, when I expand this one using the same formula as above, you should get y to the power of 4, and then you get 4 choose 1 times y to the power of 3. So 4 choose 1 is just 4, and then you should get 4 choose 2. What's 4 choose 2? 6, brill. And then 4 choose 3 is 4 again, and then just a 1 on the end. So that's the expansion of that. Okay, is everyone happy with that? And then it's gonna, and then it says, okay, so if you can do the expansion of that, and then we're going to take away this one. Well, this thing here, 1 plus y to the power 4 is all of that stuff we just wrote down. And then I'm going to take away 1 minus y cubed. Well, I've done 1 minus x cubed there, which is the same thing except the x's are y's. So I'm just going to take away this, but change it to y's. Okay, and then I've just got to simplify all this stuff. Okay, so let's just try and simplify all this. Right, so I've got y to the power of 4. I'm going to have 4y cubed plus a y cubed from down here. So 4y cubed from here, and then plus a y cubed because it's minus minus. So that gives me 5y cubed. I've got 6y squared here, and I'm going to take away 3y squared. So that's just going to give me 3y squared. I've got 4y here, and I'm going to plus 3y here, so that's plus 7y. And then I've got 1, take away 1. So that just goes. Okay, so is that what we were meant to show? That's it, isn't it? Except it's written the other way around. So 7y plus py squared, so p is 3, plus qy cubed, so q is 5, plus y to the power of 4. What do you think of that? It's pretty good, isn't it? Yeah. Okay. Oh man, this is like a pain, right? Okay. So finally, you done this bit, Shanice? Why not? Did you get there? Did you do that bit? Okay, so this final bit, it wants you to integrate this, which is not the nicest thing to integrate. Would you agree with me? Perfect. Would you agree, right? Would you agree that that thing there, the integrand, everything inside there is the same as everything I've got up here, except the y's are root x's? Is that true? Does everyone agree with that? So all I'm going to do is I'm going to write this out again. So this is the same as integrating this thing here, except the y's are going to be root x's. Okay? So this is going to be 7 root x plus 3 root x squared, yeah, plus 5 root x cubed plus root x to the power of 4 dx. So that's what I'm trying to integrate. Do you agree with that? Okay. Right. When I integrate things, I want it to the powers. I don't want the roots in there. How do I get rid of a root? How do I turn it into an index? What's a root? It's to the power of what? A half. So I'm going to go through. I'm going to change all the roots to powers of a half. So this thing here is actually 7 times x to the power of a half. Do you agree with that? What's this one? This is 3. This is 3. X to the half squared. That's just x, isn't it? Yeah? You agree with that? This one's going to be 5x to the 3 over 2. And this one's going to be... What's this one going to be? X squared, right? Okay. So I've just got to integrate that. Everyone see how I've done that? Okay? So let's do the integration of it. Should be all right. Integrate 7x to the power of a half. How do I do that? Yeah, add 1 to the power. So it's going to be 3 over 2, yeah? And divide by the new power. We'll sort that fraction out in a minute, yeah? Okay, next one. Yeah, next one. Over 5 over 2. Yeah. Nice. And? Plus c. Yeah. Okay, because it's indefinite integration. Okay, should we tidy this up? It's a nice question, isn't it? Do you like this one?
Oh, I like it now. I get where it's from.
Okay, can I tidy this up? When I divide by a fraction, what does that become there? When I divide by a fraction, how do we do that? I don't really want a fraction on the bottom of there, do I? No. 14 over 3. The number on the bottom of the fraction comes up. Okay. Yeah, okay. 14x to the 3 over 2 over 3. That is. This can stay as 3 over 2. X squared. This one then, what's this one going to be? 10x to the power of 5 over 2 over 5. What's 10 divided by 5? So that's just 2, yeah? and this one can just stay like that. That's x cubed over 3 plus c. Okay, excellent. In its simplest form, I think that is probably its simplest. Okay, so question 6. You're given the third term of a geometric sequence 36. You're given the sixth term of a geometric sequence 972. And the trick is, you have to realise that a geometric sequence would be written like this. First term would be a. The second term would be a times r, the ratio. The third term would be ar squared. Then ar cubed. And if I kept going, I would eventually get to which is a times. Oh, it's going a bit weird. I'd eventually get to a r to the n minus 1. Okay. So this third term here is ar squared, and this sixth term here is ar to the power 5. Is everyone happy with that? Okay. So I want to find out what r is. What do I do? Divide. Which one by which one? Yeah, ar to the power of 5 divided by ar squared should be the same as 972 divided by 36. Is that true?
Yeah.
Okay. The a's are going to cancel. That's the point of doing it. I'm going to lose the r's off the bottom, and I'm going to lose 2 r's off the top, so that's going to turn into a cube there. So I get to r cubed is equal to 972 divided by 36. And is that 27? Is that okay? And so r is just going to be 3, I think. Okay? Is that right? Okay. Right, so we find out what r is 3. How do I find out what a is? That's the next question. How do I find out what the first term is? Someone talk me through that? Yeah, well, we actually know that ar squared equals 36. So it must be that a times by 3 squared, which is 9. So 9a must be 36. So that must mean that a is 4. So the first term is 4. Okay, everyone happy with that? Okay, the next part is we've got to prove or show that this summation is true. Now to do that, we need to use this formula, which is in the formula book. For a geometric sequence, I can sum up the terms in a geometric sequence to the nth term. The sum of the first n terms is going to be a, first term, times by 1 minus the ratio to the power of n, there, all divided by 1 minus r. Is everyone happy with that? That's in the formula book. So the sum of the first 20 terms, which is what this is asking us about, should be a, which was 4, times 1 minus 3 to the power of 20, divided by 1 minus 3. Okay, so let's just do some stuff with this. That gives me 4, 1 minus 3 over 3 to the power of 20 there, and then on the bottom I just get negative 2. And that just gives me minus 2 times 1 minus 3 to the power of 20. I can take that negative in front of the minus 2 and put it inside the bracket, which just gives me a 2 there, and inside the negatives will become positives, the positives will become negatives, so I get that. Okay, is that okay? And then that thing there, that sum of the first 20 terms, is the same as saying, or let's write it like this, the sum of the first 20 terms is equal to me saying this, the sum from n equals 1 to 20 of that, and we've just shown that it can be written like this, 2, 3 to the power 20, and that's what we've got to show. Is everyone happy with that? Okay, so that's quite nice. A lot of the series and sequences are just plugging things into those formulas you get. Okay, decide whether it's a geometric sequence or an arithmetic. and then decide whether it's asking you for the sum or the position, and just sub the things in, usually. Okay, last question. Find the least value of n such that un is greater than 4 times 10 to the power of 15. Someone talk me through that. What's un? I don't think it is, you know. We just found the sum of un, didn't we? It's like the nth term, yeah. Brilliant, yeah. So un is a r n to the minus 1. Yeah, I agree with that. And we want that to be greater than 4 times 10 to the 15. Now, first thing you got to remember about this is, can n's got to be an integer, right? Okay, so whatever we get, we'll probably get n as a decimal, and then we'll decide which value of n we need. Okay, so what did we get for a? We got 4. We got 3 here, n to the minus 1, and we want that to be greater than 4 times 10 to the 15. Is that right? Divide by 4. Should we do that? That just gives me 1 times 10 to the 15. Okay, what do we do now? Well, we're trying to find out what the n value is, so what would I do? Yeah, whenever you're trying to find out something that's up there in the power, whenever the thing you're trying to find out is the power, that's logs. That's how you do log. That's what logs are for, finding out what's up there. Okay, so I'll log both sides. So log 3n to the minus 1, we want it to be greater than log 10, 15, like that. Take this n to the minus 1 out front, that's the point. Okay, the power can come down. Now, what's log 10 to the 15? Yeah, it's 15 log 10. That's what you said, Shannon, yeah? What's log 10? Yeah, because log is base 10, isn't it? Okay, so I use log here, and that's going to get rid of that. So log to the base 10, which is what log is, 10 is just going to be 1. So here I get n minus 1. You don't have to do it like that. You could have used it. Could have used ln, but we're using log, so would have got the same answer. That's 15. So n minus 1 we want to be greater than 15 divided by log 3. And so finally, n has got to be greater than 15 over log 3 plus 1. Okay? Is everyone happy with that? So I'll grab my calculator and do 15 divided by log 3, add 1. So n has got to be greater than 32.4385. Okay? So what's n then? 33. N's got to be a whole number. Okay? So n equals 33. First thing we want to do is find dy dx. So, can we do that? Can we find what dy dx is? Well, first of all, before I find what dy dx is, it's probably best to write this expression for y in terms of indices rather than 1 over x to the 4. So, I'm going to change it to x plus 3. And this last term, is there a better way I can write that for differentiating? 8x to the minus 4, perfect. Okay, so someone should be able to differentiate that then. What happens to the x? It goes to 1, the 3. That goes, and then this 8x to the minus 4, what happens to that?
32x to the power of minus 5.
It's minus 32x. Okay, because it gets times by minus 4 to the power of minus 5, absolutely right. Everyone agree with that? Yes? Guys, can you pay attention please? Do you agree with that? Is that right? Okay, so we want the tangent we want the tangent at x equals 1. So that's the gradient, okay? That's the gradient of the curve at any point we want. So if we want the tangent, so this is part B, the gradient at x equals 1 is going to be 1 minus 32 times 1 to the minus 5. Is that right? I've just subbed 1 in. 1 to the minus 5, what's 1 to the minus 5? 1. So this is 1 minus 32, so that's take away, it's minus 31, right? Okay, so the gradient at x equals 1 is going to be minus 31. What else do I need to find the equation of the tangent? I need a coordinate it goes through. I know that the x value is 1, so I need the y value at 1, but I can use the equation that I've got for y, sub in 1 into that, and I'm going to get 1 plus 3 plus 8 over 1. Do you agree with that? I'm going to sub in 1, and I'm going to get 4 plus 8, which is 12. Okay? So what I know about this tangent line, Josh, got to pay attention. Okay? What I know about this tangent line is the gradient is negative 31, and I also know it goes through this point 1, 12. Okay? So how do I find the equation of the line now? Anybody? Yeah, y minus y1. Okay, and I sub in the values. So it's y take 12 is equal to minus 31 x minus 1. Okay. Okay, and that's the equation of the tangent. Who managed to get that? Did anyone rearrange it? Should we just rearrange? I'll just you get all the marks for getting it to there, but if you want to rearrange it, you're going to get y is equal to minus 31 x plus 31 plus 12. So what's that? Plus 43. Did anyone get that? Is that okay? Okay. Now, next bit. The curve has a minimum point at point M. Okay. How do I find a curve's minimum point? Can someone tell me? Equate what to 0? Yeah, the gradient will be 0. Okay. So the curve is stationary. We call it stationary point. It's stationary when dy dx equals 0. Okay, we've already worked out dy dx. It was 1 minus 32 x to the minus 5. So let's put that equal to 0. 1 minus 32 x to the minus 5 is equal to 0, and we want to find the x value that makes that true. Now, when you're solving these things, it's best, I would say, to change that back into a form like that. Okay, and so I'm going to get that 32 over x to the power of 5 is equal to 1. Okay, and then I'm going to get that x to the power of 5 is equal to 32. And so can someone tell me what x is? X equals 2. Okay, so x equals 2. It wants the coordinates. This is why it's 4 marks. I've got the x value. How do I find out the y value? I sub it back into y, yeah. I sub it into the y, so I'm going to sub 2 into there. That's the x coordinate when it's minimum. So I sub in 2 back into the y, so it's going to be 2 plus 3 plus 8 over 2 to the power of 4. Okay. What's 2 to the power of 4? 16. Okay, so this is 5 plus a half, isn't it? So that's 5.5. Okay. So the coordinates of the minimum point, coordinates of the minimum are 2 and 5.5, which is 11 over 2, right? Or 5.5 or whatever you want. Okay, who managed to do that? That's like 7, that's 13 marks on this question already, right? Okay, part part D, it's asking you to integrate this, x plus 3, integrate the curve. And we've already said that we can rewrite that. It's better to integrate that if you have it in this form, x plus 3 plus 8 x to the minus 4 dx. Okay. Right, so can someone integrate this for me? Someone differentiated it for me earlier, so can someone integrate it? The x is going to go to what? X squared over 2. The 3 is going to go to 3x. 8x to the minus 4, what does that go to? Yeah? Brill. Okay, so it's going to be 8x to the negative 3 divided by minus 3, so that it's going to be negative there. And there's a plus c as well, right? Okay, so that's the integration, that's your 3 marks. It's then saying, hence find the area bounded between 2 and 1. Well, the area bounded between 2 and 1 is the same as me saying, what's the integration between 2 and 1 of the thing we just did. Dx. So it's saying that would give me the area between 2 and 1, do you agree? Okay, and that's going to be the thing we just got as our solution when we integrated it, but I've just got to sub in, I don't need to worry about the c now, I've just got to sub in 2 and 1, and that's going to give me the area. Okay, so let's just quickly do that. Okay. Where's it going up? I'm dragging it down. Oh, it's there. Come on. What's going on? Okay. So first of all, sub in 2. So we get 2 squared over 2. That's 4 over 2. That's 2. Plus 3 times 2. So that's plus 6. And then I've got, what's this going to be? 8. If I sub 2 in for x to the minus 3, what's 2 to the minus 3? What's 2 to the power of minus 3? 1 over 8. So it's 8 times 1 over 8. So that's just 1. So this is just minus a third. Okay. And then I'm going to take away when I sub in 1. So this is going to be a half plus 3. And then I'm going to get minus 8 over 3. Okay. I've just got to simplify all this. I think you only get 1 mark for doing this last little step. So this is 8, take away a third. And then I'm going to take away, what do I get here? I can't do this sort of thing. What's this? This is 1/2 plus 3. What's this? This is 2 plus 2 and 2/3. Yeah. Yeah, minus, sorry, you're absolutely right. Minus 2. Minus 2 and minus 2/3, right? Okay, 1. I take away a half, right? 6.833, is that right?
Yeah,
6.8. How's that? Is that good? Okay. Last one. The curve is translated by 0k. Okay. Given the x-axis is now tangent to the curve. Okay. State the constant k. Can anyone tell me? It's now tangent. How do you know? Yeah, so what Kat's saying is this minimum point here, okay, was at the coordinate 2. We did work it out. It was at the x coordinates, the x coordinate was 2, And the y ordinate was 5.5, wasn't it? 11 over 2, 5.5. Okay? So that's the coordinate of that minimum point there, yeah? So it says if we are to translate this curve so that the x-axis is a tangent, we're going to have to move it down 5.5. Okay? Is that true? So k is going to have to be negative 5.5. Okay? And that's the last little bit. Okay, question 8. We're trying to find out a value. Is that what we're trying to do? Find a value of k? So the first thing I would do here, I would see that 1 on its own. Whenever you've got a log equation there, and it's got a 1 in, you've got to remember one of the rules of logs is that you can write 1 as log to the base of something of that. Okay, so 1 you can write as log kk. And now what I do is I'll put all these logs together. So this first one here, I can take the 2 from in front and write it as x squared. Just do one thing at a time so they can mark it. So I would have got a mark for doing that. Okay. Then I'm going to put these 2 logs together, and when I take away logs from each other, it's just the same as dividing. So this is just 1 log to the base k, x squared over 5. And that's equal to log k. And now I've just got 1 log equal to something else. So log x squared over 5 is equal to log of k. So I can just get rid of the logs now and just say that x squared over 5 equals k. And what we're trying to find out, what k is. Yeah, so that's it. K is x squared over 5. Okay? How's that? Is that okay? Any questions? Okay, for part B looks nasty, but it's all right really. So part B, it says log A. I'm going to do this one thing at a time, okay? It says log to the base A of y equals 3 over 2. Can you see that? So I'm just going to, before I do anything with this, does that mean then that a to the power of 3 over 2 is equal to y? That's true, right? Okay. Go to the next statement it gives me. Log to the base of 4 of a equals b plus 2. Hold on a sec. Can I do something with this? Let's see, this is asking me to do log to the base a. Can I get a on its own? How do I rearrange that so it's a equals rather than a to the power 3 over 2? What does that 3 over 2 mean? Yeah, it's a cubed and square rooted. So what does that mean a is? A is what? No. Y squared cube rooted, yeah. Is that true? Okay. So let's come up back over here. Am I doing this right? Hope so. This is log to the base 4 of a. Well, a is just that, right? Y to the power of 2 over 3. And that's equal to b plus 2. Right, does everyone agree with that? So the first thing told me what y was in terms of, told me what y was in terms of a, and I've rearranged for a in terms of y. And the second thing gives me an expression for a, so I've changed it for y. And now I've just got to deal with this thing here. So this thing here says that log to the base 4 of that equals b plus 2. So that must mean that 4 to the power of b plus 2 is equal to y to the power of 2 over 3. Is that right? Do you agree with that? Okay. 4 is 2 squared, isn't it? Yeah? So I've got y to the power of 2 over 3 is equal to 2 squared, that's 4, to the power of b plus 2. Okay? So this is y to the power of 2 over 3 is equal to 2 to the power of... Now, what's the rule when I do times them? Yeah. So this is 2b plus 4 there. Now, what about these things here? How do I get rid of the 2 and 3 over here? How do I get rid of that 3 on the bottom? This is just going to be, what, 6b on this side, is it? 6b plus 12. Yeah, and then get rid of that 2. That's going to be... How's that? It says write down, show that y equals 2 to the power of p, where p is an expression in terms of b. So p is equal to 3b plus 6. What do you think of that? Is that nice or nasty? Yeah, it's not nice, is it? This is question 9, and part A is just, can we solve this equation tan x equals negative 3 in the region 0 to 360. So all I'm going to do is just do inverse tan on negative 3, and I'm working in degrees, so I'll just grab my calculator, and it's going to be inverse tan negative 3, and it says minus 71.56. In fact, it says to the nearest degree, so that's minus 72. Okay, is minus 72 in that range?
No.
No. So minus 72 would be like down here somewhere. Do you agree? Somewhere over there. So where's the values in my range? Over here. Let me just draw on this thing. This is 90 degrees here. This is 180. This is 270. This is the tan graph. So it was at negative 72 over here. Where else is it going to be in this range? It's going to be
180 minus 72.
Yeah. So 180 minus 72, and 360 minus 72. Do you agree? So the x values in this range, what do I get? 180 minus 72. 108. And what's the other one? 280. Perfect. Right, who managed to do the first part? Okay, that's a pretty standard question. The second bit is the one that I saw this come up this year, and it stumped me for a little bit, and it takes a little bit of thinking about. You've got this here, sine theta cos theta equals 6. Okay, just look at this, please. Now, what's the problem with that? Why can't we solve it, first of all? Identify the problem with it. It's got a sine and a cosine, but it says that you should be able to change it into just tans. Okay, so what's an obvious thing to try? There's kind of like an obvious first thing to do. Divide by cos squared would be a good idea, Callum, yeah? Okay. Now, when you're trying to change, when you've got something and it's got sine and cosine in, you know you've got to use an identity. And there's two identities you have, and that's that tan theta equals sine over cosine. And you also know this other identity, which is sine squared plus cosine squared is equal to 1. Okay, and if you want to change sine squared, you can use this identity here if it's squared, and this one's changed into tan. And you usually use one of them, and it will sort it out. So, because it wants you to have this thing in terms of tan, it's probably best to use this identity on the left, right? And Callum's saying it might be a good idea to divide by cos squared. Let's see why that's true. Divide both sides by cos squared. It seems like an obvious idea, and what you get is sine squared theta over cosine squared. So I'm just dividing everything by cos squared. Over here I'm going to get sine theta cos theta over cos squared. And over here I get 6 over cosine squared. So I've divided everything by cos squared, so it's okay. Sine squared over cosine squared, what does that give me? Tan squared. What happens here is on the bottom I've got cos squared, I've got cos times cosine. I've got cosine times cosine. So one cosine is going to cancel with one cosine there, and then I get plus tan. And then here I still have this. Now, in one sense it's good because I got tans over here, but in another sense it's bad because I've made another cosine over here. Okay, so that's not actually the way to do it. It seems like the obvious thing to do, but it doesn't help you out. Okay, so here's the trick. I know we're running out of time, and it's a trick that a lot of people would never ever think to do, but once you've seen it, you need to remember it. And this is the trick. Okay, we'll write it down, and then I'll see who can spot what I've done. Okay. Okay, can you see that? Am I allowed to do that?
Yeah.
Why am I allowed to do that? Because that's just 1 over here. So I see the 6 on its own, and rather than just write it as 6, I'm writing it as 6 times 1. Okay? But the 1 I'm going to write like that. Okay? Now if I multiply this all out and rearrange it, I should get to where I was. Okay? So let's have a look. So I get all of this. Yeah, it's something you wouldn't spot, but the next time you see it and you can't get the answer, if there's a number on its own and you can't get it into the shape that you want it to be, if there's a number just sat there on its own, you can always write it as that number times by sine squared plus cos squared. Okay, it's a bit like when you see a number on its own with the logs, you can always write that number. Say you had 5 on its own in a log equation, you can always write it as 5 log to the base a of a. You see what I mean? So you can always do that. Now all I have to do is rearrange. So I'm going to bring the sine squared over here. So that leaves me with 1 sine squared theta plus sine theta cos theta. And I'm going to bring that minus, I'm going to bring that 6 cos over there. Okay, and now the last step is, just stay with me for a second. The last step is what Callum said at the start. Now if you divide it by cos squared, it should work. Okay, so I'm going to get sine squared theta over cosine squared theta plus sine theta cos theta over cos squared theta. And over here I'm going to get minus 6 cos squared theta over cos squared theta. That all equals 0. What does this bit go to? This bit just goes to not 1, tan squared. This bit goes to 1 cos is going to cancel with 1 cos on the bottom, so this is just tan. Sorry, this should be a... Oh, that's right, isn't it? No, the 7's gone. And this bit is just negative 6 here, isn't it? Negative 6 cos squared cancels with cos squared, and I get that. And that's what you're trying to show. Okay? Yeah. Okay, so finally for the last part, we've just got to solve. So this is B part 2. For the last part, we've got to solve 7 sine squared theta plus sine theta cosine theta is equal to 6. Well, we've just shown that that can be rewritten as what we've just done. So that's the same, it will have the same solutions as this problem here. And this problem here is just a quadratic, and I can factorise it. And it's going to be tan theta and tan theta over here. And it's going to be plus 3 and minus 2. So this thing is going to have solutions when tan theta equals minus 3 and when tan theta is equal to 2. Now, when tan theta equals minus 3, we've actually already got the solutions for it in the region 0 to 360. So I can just go ahead and write those down. Theta, the values of theta in that region are 108 and 288. So all I've got to do now is just solve tan theta equals 2, which I do exactly the same way as I did at the start. I do theta is the inverse of that. I just do it on my calculator. So inverse tan of 2, 63.43. And it's to the nearest degree, so it's 63. And then I go back up to the graph of tan, and 63 is about here. So the next one is going to be at 180 plus 63. Which is going to be 243. Okay, so the values of theta that satisfy that quadratic then are 63, 108, 243, and 288. So there's 4 solutions. 2 from the one factor and 2 from the other.